Hello, my friends, and welcome to Origins. My name's Don Chapman, and I'm your host. Origins is a forum where we use the evidence of science to validate the truth of creation. We do that by interviewing scientists and apologists who bring us their fresh perspective and research. Dr. Vardiman, it's so good to have you with us.
Glad to be here, Don.
We're really going to talk about 8 years of your life, aren't we?
That's right.
Now, let me just tell the folks that you are the research coordinator and the chairman of the Astro Geophysics Department at the Institute for Creation Research. Did I get that right?
That's right.
And we're going to talk today about something called RATE.
RATE stands for radioisotopes and the age of the Earth. Now,
everyone always asks me, what about carbon dating? But they're not really talking about just carbon dating. They're talking about dating using radioisotopes. Isn't that true?
Right. You look at how much carbon-14 is still in the sample after a number of years, and from that you can estimate how long it's been since the organism died.
But you just used the word organism. So when we're dating rocks and the Earth as a whole, carbon's no help to us.
That's right. You have to use long-age isotopes, which date the formation of the rocks, and that doesn't have anything to do with living organisms.
So lots of times when people talk to me about carbon dating, and I think they think you can read carbon dating like you can read a Timex watch, but they're really talking about radioisotope dating.
That's right. It's a little
bigger
bit
category.
That's right. You can't just pull it off there. What you're doing is actually measuring ratios of carbon-14, which is a radioactive element, with carbon-12, which is a non-radioactive, and you can get that ratio, and from that you can infer time.
Tell us, just to get us started, what is a radioisotope?
Well, an isotope is a variation on a particular element. For example, oxygen has an atomic number of 16, but you can also have one that has an atomic number of 17 or 18. It varies the number of neutrons in the nucleus. So each one of those is an isotope.
Okay.
One that is radioactive is a radioisotope.
All right. That'll have to do for now, at least. Now, tell us about RATE. This is really exciting, and I want our viewers to be with us, to track with us on what you've been doing for the last 8 years. And so kind of tell us the story.
The RATE project, as we call it, started in 1997. And this was an 8-year research project that was started by the Institute for Creation Research and the Creation Research Society. And the idea was to confront the issue of the age of the Earth and the biblical estimate of on the order of thousands of years, whereas the conventional viewpoint is that the Earth is billions of years old. This is a big issue in the Christian community because when you're a Christian and you want to believe what science is telling you, and it says billions of years, and yet your Bible says that the Earth is thousands of years old, if there's such a conflict here, how are you going to believe anything the Bible has to say?
And up until your research group has gone to work, basically our people would go to university and the science teachers would present to them scientific evidence. They come to church. We just read them verses. We didn't really have any scientific evidence. But you guys are changing that, aren't you?
That was exactly the purpose of RATE. We felt that we had to address this problem. We put together a group of scientists who each had specialties in this area and were very committed to Scripture. Our team first met in San Diego to discuss the techniques used for dating the Earth. We reviewed the way rocks were being dated and found these methods to be questionable at best. Up until this point, supporters of a young Earth had criticized the conclusions drawn from dating rocks, but had not offered any explanation for how large quantities of decay products from radioisotopes in the rocks had been formed in such a short period of time. It was these decay products, like lead, that had been used to argue that the Earth was old. Rather than simply denying the claims that the Earth was old, our team determined to understand what processes may have formed the decay products. If we could find evidence for their source, then we might be able to explain the enormous difference between the billions of years estimated by many conventional scientists and the thousands of years concluded from a literal understanding of the Bible. To appreciate what the RATE team discovered, we must first understand the process of nuclear decay. To do this, Let's look at the common illustration of an hourglass and compare nuclear decay to the sand trickling from the top to the bottom. Imagine each grain of sand representing an unstable atom called a radioisotope. During nuclear decay, these radioisotopes change into entirely different elements. For example, from uranium to lead. The rate of this nuclear decay can be measured, theoretically allowing the age of a rock to be calculated. Continuing the hourglass illustration, the sand in the top can be compared to unstable atoms, or parent isotopes. The sand at the bottom represents the decay products, or daughter isotopes. In nuclear decay, the parent isotopes, sand on the top, is always unstable and over time changes to daughter isotope, sand on the bottom. The rate of sand trickling from the top to the bottom represents the rate at which parent isotopes decay into daughter isotopes. In other words, just as a person can calculate how much time has elapsed by observing the amount of sand in the bottom of an hourglass, in theory, the amount of daughter isotopes in a rock can indicate its age. However, creationists have pointed out that this straightforward dating concept is unreliable because it's based on three unprovable and questionable assumptions. First, it assumes that the amount of parent and daughter isotopes have not been altered by anything except radioactive decay. Second, it assumes that when the rock was formed, it contained a known amount of the daughter isotopes, in many cases believed to be zero. And third, and finally, it assumes that the decay rate has been constant throughout history. Until recently, creationists have pointed out serious flaws with the first two assumptions, citing contamination in numerous examples and unknown initial conditions. But now, recent discoveries by the rate team are beginning to challenge the third assumption, that the rate of decay has been constant throughout time. The results from the rate team's research strongly support the contention that the Earth is young, and nuclear processes have been accelerated in the recent past.
And God was preparing you for this all your life, wasn't He?
Well, I look back on it and I believe he was. I worked for the government for many years, directing field activities, and so I was able to coordinate universities and government agencies and private companies and handle millions of dollars of funds. So I learned how to administrate this kind of a project. My own background in atmospheric science was not really adequate for this kind of research, but I had the capability of being able to coordinate the effort, raise the funding, and be able to tell people what we were accomplishing. And it's a real challenge to be able to provide the resources that they need, to be able to encourage them and get them to work together. Now, this is the first time that this type of major research effort was done in the creationist community, because we spent over $1.5 million of donated money for this over a period of 8 years to be able to run this program. And it's the biggest program of this kind that's ever been done in creation science.
Well, I'm excited, and I could say a lot of other things, but I don't want to take your time from sharing with us. We're going to talk about this classic paradigm that's there, that the Bible, if you read the Bible at face value, it's very clear that God made the world in 6 days, and He did it a few thousand years ago.
That's right.
And when you go to science, it's billions and billions of years ago.
And it didn't have anything to do with God.
And there's no God out there. We made Him up later.
That's right.
So you're trying to say, well, let's look at this as scientists and see if there really is evidence in the rocks for a young Earth.
That's right.
Tell us about phase one.
Okay. It was organized into two phases. The first phase lasted 3 years, and the second phase lasted 5. The first phase was a 3-year development of the research proposal. If you know anything about graduate school and research, the student is expected to say what he's going to do. He has to do a literature search, he has to state the problem, and explain how he's going to go about solving that particular problem. In a sense, that's what the first 3 years of this project was all about. And it resulted in the rate book, the first result that came out, and it essentially was a research proposal. It reported on all the library research that we did. It reported on all the ideas that we had. In fact, when we started this project, the scientists who were involved in it had different ideas of how to go about solving the problem. We couldn't take all of those ideas and try to approach them all. We had to come to some kind of agreement as to what our hypotheses were going to be for this project. And that's basically what the first rate book was. It was reporting on that. It's essentially a research proposal. It was bolstered with a glossary in the back and a lot of the other information that was necessary for this project to go on.
So that's really a book of questions.
Yes, it asks what is the question that we're going to answer.
Yes.
It's the hypothesis that we have. The phase 2 was the research phase, and it was 5 years long. We met once a year in San Diego and discussed for 2 days the progress that we had made, the proposals we were going to do for that year, and what kind of funding that we had to be able to work on. And I might just stop here and say that we received sufficient funding to do everything that we needed to do in this project in exactly the time frame we needed. So that by the end of the 8 years, we basically spent $2 million for the whole project.
And you've really... That's one way of saying you've really seen God's hand in this along the way.
It's magnificent to see what he did.
Praise God.
But he not only provided the money, people prayed for us as well.
Amen.
We asked for people to pray for us.
Amen.
And God provided the initiative, the incentive, the creativity that we had to be able to approach this problem. Well, the phase 2 ended in the year 2005. And we had a second rate book, a non-technical book for the general public that tried to bring that information down to a level that was understandable, and a video documentary. This is the final rate book. I might say also that this particular book is written to the scientist or
Yes.
the student or the graduate student. It's really a highly technical book. You should not at all be embarrassed about purchasing this book and giving it to your science friends.
Good.
I mean, it is an honor to be able to have that kind of a book come out of this. The person in the pew really can't grasp a lot of the concepts in there, so we wrote another book. Don D. Young, who's a professor at Grace College in Winona Lake, Indiana, wrote a 200-page paperback edition, which is an attempt to try to bring it down to the level that the person who has a technical background but not highly trained could understand that.
And this would be a book that many of our viewers could really benefit from.
Yes, we've sold thousands of these books to the general person, and they've been able to understand that very well. Then we also did a DVD in which we interviewed each of the scientists and let them explain what they were doing and why, and also presented it in a way that was understandable to the general public. Okay, one of the results that we had is the rate of helium diffusing out of rocks. Granite has little zircons in them, and we found, surprising to us, a tremendous quantity of helium still in those little zircons in the rocks, which is a result of the fact that there was a lot of radioactive decay in a short time in the past, and the helium is still there. If the Earth was billions of years old, that helium should not be there. And we actually measured the rate at which it diffuses out, and we're able to estimate the age of the Earth at 6,000 plus or minus 2,000 years. So basically our best estimate from the helium diffusion directly in the laboratory is that the Earth is 6,000 years old.
Now that is so counter to all the research done before you that it's revolutionary, isn't it?
It really is, and
Yes.
we're going to come back and talk about that and how that relates to the decay of uranium into lead and the uranium into helium, which we measure here. The second animation here is having to do with another evidence for a young Earth, and that is the polonium halos that we find in these same zircons and the biotites surrounding them. Turns out that these little zircons that we talked about a moment ago have uranium in them that decay and produce polonium isotopes, which in themselves are radioactive, and they leave telltale damage in the rock called halos. The polonium halos occur so rapidly that the process of forming them had to be catastrophic, happened extremely rapidly just a short time ago. And we're going to talk about how that occurs, but this is also very strong evidence to something we call accelerated decay, which is our biggest result of this whole project.
And the third thing is really exciting because I don't know anybody out there, especially the ladies, that don't like diamonds. So let us know what that has for us.
All right. We found, completely surprised, it wasn't originally part of our project, we found carbon-14 in coal and diamonds. Coal is supposed to be 100 million years old. Diamonds are supposed to be billions of years old. They should not have any carbon-14 in them because it decays so rapidly. And yet we were able to find carbon-14 not only in the coal, but in the diamonds, and that was the first time that had ever been reported in the scientific literature.
The first time ever that carbon was found in diamonds, you guys did it.
Right, and so this is the third evidence that the Earth is young.
That's incredible. We've got to go to a break right now. I just again want to say that show is going to be a show that none of our people are going to want to miss. So you're bringing us some great material. We're so blessed you're here. We have to go to a break, but when we come back, we're going to just kind of draw together the conclusions of what rate has done for us and how it's going to impact the whole creation-evolution debate. Don't go away.
Creation versus evolution. You weigh the evidence. Mount St. Helens, a new geologic story. There is extensive evidence that the layers of strata in the geologic record have been laid down very quickly, similar to the processes observed since Mount St. Helens erupted. The major formations of the Earth's crust are sedimentary rock beds formed by rapid erosion, transportation, and deposition by water. Rapid global formation of sedimentary rock beds is evidence that the Earth is thousands, not millions of years old. Today's guest on Origins, Dr. Larry Vardiman, is chairman of the Department of Astrogeophysics at the Institute for Creation Research's Graduate School. Through his ongoing research in atmospheric science, Dr. Vardiman has contributed much to the field of creation science. He also led the RATE team, a research project examining the age of the Earth. This has been documented in the DVD, Thousands, Not Billions. For more information, contact the Institute for Creation Research, 1806 Royal Lane, Dallas, Texas, 75229, or call 1-800-337-0375. Or visit the website, www.icr.org.
Dr. Vardiman, we're back, and you're going to give us some conclusions. First scientific conclusions, and then some scriptural conclusions from your research. So help us first with the science.
Okay, well, it was exciting to be able to find at the end of 8 years that we had significant conclusions. It's quite often in research projects that the research just goes on and on and on. We set this up in such a way that we were going to report back to our constituency at the end of 8 years, whatever we found. And we were just thrilled to be able to give the conclusions that we did. The first one, which was a surprise to us, was that a large amount of radioactive decay has occurred in Earth history.
Now, you really were kind of hoping to find a little bit of decay, weren't you?
Right. We were hoping that this would be the explanation. There really wasn't all this decay that everybody talks about. But from the fission track analysis we did, we haven't talked about that yet, but the fission track analysis, it is a clear evidence that there was a tremendous amount of radioactive decay. And in fact, if you're an old earther, or if you don't believe in God and you believe that the Earth is billions of years old, this radioactive decay at the rate it occurs today would give you billions of years.
Yes. Okay. So, but that's not where it ends. Keep going.
Okay. But we found large quantities of helium and radiohalos in granite and carbon-14 in coal, which are strong evidence for a young Earth. Those are not compatible with long ages. In fact, there is direct evidence from each one of those that the Earth had to be very young, and that this large amount of radioactive decay occurred just a few thousand years ago. That's why we named our book Thousands, Not Billions. And then finally, to be compatible with that evidence, basically the conclusion is that nuclear processes were accelerated during certain periods of Earth history.
Now that's new, isn't it?
That's new, and it's also extremely controversial. And it was hard for us to be able to accept that at first. When we started this project, we didn't anticipate that. And in fact, most of us would have said that can't be, because we'd all been trained that nuclear decay processes do not change, or if they do, it's less than like 1% or something like it. No matter what the chemicals you throw at it or the heat or so on, it doesn't change nuclear processes. But the evidence we found now says that it had to have changed, and we call that increase in decay rate accelerated decay. The three evidences we have for accelerated decay comes out of the helium diffusion that we have. We already mentioned earlier in the program, the decay of uranium into lead also produces helium as a byproduct. And the helium is still in the rocks. And if that happened in a short period of time, it indicates that this decay had to have been speeded up and produced accelerated decay. So there is a first piece of evidence. The second one is the radio halos. We'll talk about this again, but the way in which the polonium radio halos had to form, it had to have happened in a very rapid period of time under catastrophic processes during which the nuclear decay rate was extremely fast.
And we have whole shows coming up on both of those topics.
Each one of those will have its own program.
Don't miss them, folks.
And then finally, the carbon-14 in coal and in diamonds. That itself is kind of a general conclusion, but it supports the idea of a young Earth. And if all this had to happen in a short period of time, it again implies accelerated decay.
You said to me off the air that they have equipment now to measure carbon that we didn't have even 10 years ago.
That's right. About 10 years ago, a new kind of equipment called an accelerator mass spectrometer was developed that could measure extremely small quantities of carbon-14, and that's what allowed us to be able to find the carbon-14 in the coal and diamonds.
So up until 10 years ago, I just see the hand of God in the timing of your RAID committee coming together, that right when the equipment is there for this, you guys are launching your program.
Right. It's exciting. Well, in addition to the scientific conclusions, we have some scriptural conclusions that come out of this, and that is that creation and the flood are genuine historical events. They really happened in Earth history. And based on that, that gives us a confidence to say that the Bible is scientifically reliable.
Those are two very huge statements you've just made, my friend.
Yes, they are. And it's really satisfying to be able to say that.
And you're saying that with real confidence after doing your research.
Yes. In fact, that's one of the reasons I've done this kind of work, and all of us involved in RATE did, was because we wanted to be able to bring more confidence to people that the Bible is reliable. We as Christians quite often don't have the confidence in it, and therefore we don't apply it in the world around us because we don't have that real gut level feeling that it's true.
Especially in the educational setting.
You got it.
Yes. Well, you know, I just had one sentence from your book that I wanted to read. It says, this book opens a new chapter in the origins controversy. We have new scientific evidence that's never been done in the creation research community before that this great group has done. And the evidence that they have to give to you will not only renew your confidence, but give you new ammunition as you speak to others with certainty about how God created the world, how He is the Lord of the earth. Because if He's not the Lord of the beginning, He's not the Lord of the end. If He's not the Lord of creation, He's not the Lord who can give us eternal life. But He is the one who made us. He is the one who rules. He is the one who judges. And He is the one who, in His love, has made a way for us to have eternal life. Please, my friends, be with us in the weeks ahead as we unpack for you this incredible evidence about how God made this earth in 6 days about 6,000 years ago. It's revolutionary. You won't want to miss it. And above all, you want to remember this. It's God's view that He created you. And that should be your worldview too. Be sure you join us next time. Thank you, Dr. Vardiman, for your tremendous help in this area.
Thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 812 from our website at www.originstv.org. or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins Program, number 812, Cornerstone Television, Wall, Pennsylvania, 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.
Hello, my friends. Welcome to Origins. My name is Don Chapman. It's my privilege to be your host. We like to say that Origins is a forum where we take the evidence of science and use it to validate the truth of creation. Our guest today is Dr. Larry Vardiman. Dr. Vardiman, how good it is to have you here with us.
Thank you, Don. I'm glad to be here.
Now, you are the coordinator of the RATE group.
Right. The RATE project is Radioisotopes in the Age of the Earth, and I was kind of the organizer of it and the administrator.
We're going to talk about helium today.
That's right.
But we're not going to talk about blowing up balloons for birthday parties.
No, we're going to talk about helium in rocks. Helium is one of the byproducts of uranium decay. Uranium is a heavy element that breaks down into lead, and it also produces helium at the same time. The uranium is what we call the parent element, and the lead that it's produced and the helium are the daughter elements. And so nobody's ever looked at the measurement of helium in dating rocks, but we've done that and found that it's completely different than if you looked at the lead that is produced in the rocks. And this really addresses what we call the icon of evolution, and we are actually coming up with alternative ages for the age of the Earth, which actually fit into the Bible. And the first one we want to talk about today is helium diffusion rates.
All right.
This helium that's created in the rock by the decay of uranium becomes an alternative dating method or a clock for estimating how old the rocks are. Before I get into that in detail, let me just give you a few of the basic assumptions for radioisotope dating. Radioisotope dating is the primary method for dating rocks, but it has some basic assumptions in it that have to be met. And for this situation, one or more of these may not be valid. The three basic assumptions are that there is no initial concentration of the daughter elements. In other words, if you're going to have a clock, you have to know where you start from. And the assumption is you start from zero, and however much you have, whether it's lead or helium, that tells you how long the clock has been running.
So there can't be helium or lead there at the beginning.
That's right.
Okay.
Or if there is there, you had to know how much there was,
Right.
but we have no way of knowing that.
Right.
So you assume that there's none there. The second assumption is that there's a constant decay rate of the uranium into lead and helium. Now, we can measure the rate at which uranium decays today, but we just assume it's always been that way. Now, those of us on the RATE project assume, like the conventional scientific community does, that that's been the case. And in fact, we figured that that would be the hardest assumption to overthrow, but the results of this experiment actually dealt with that particular assumption and found out it wasn't true. The third one is that the system that we're looking at, it has to be closed. Now, what that means is that the amount of uranium that's there to start with has to be the same throughout the process.
Sure.
And that there's no additional uranium added to the system or taken away. or there's no helium or lead added or removed from the system by any other process than the decay of uranium into lead and helium. Now, that also is a very difficult assumption to be able to demonstrate, and there may be some, that in fact was the assumption we thought would be the biggest one to deal with, but the constant decay rate was really what came out in our results. When we started the RATE experiment, RATE stands for Radioisotopes in the Age of the Earth. When we started this experiment, we spent 3 years understanding what we were going to do in the major part of the project, and then we spent 5 years doing the experimental phase or the research phase. And at the end of that first phase, we had a set of questions that we said we were going to try to answer in the research phase. These are the basic questions. We had already come to the conclusion that the process of decay had to have been accelerated in some way, and we were going to try to see if we could demonstrate that. So our first hypothesis was that accelerated decay has occurred during creation, at the curse, and or during the flood, the Genesis flood we're talking about. A second hypothesis was that some daughter elements may have been primordial. That means that some of them were there to start with. For example, some of the lead, we in our experiment found that we could explain most of the lead, but some of it had to have been there in the original creation. We couldn't explain it all. And finally, we made the hypothesis that radioactive processes have produced evidence of accelerated decay. Now, we weren't sure we were going to be able to demonstrate that, but through the experiment, we actually were able to show that. And that's what was really exciting about this project.
Well, share with us what you've discovered.
Okay, let me start off and give you a little bit of background to how we did some of the experimentation. We did a lot of this work in our own laboratory, preparing the samples that we were going to send off. And I might say that we did the experimentation by using conventional laboratory work. And the reason we did that was it was going to be very expensive for us to set up our own laboratories for a whole bunch of different type of analyses. These labs cost hundreds of thousands of dollars each, and you have to have a technician who's well trained, and the lab has to have been established for many years. We didn't have the time or the money to do that kind of work. But more importantly was that most people would not believe the results if we did it in our own lab. So we sent these off to conventional labs, had them do the analysis, and then we did the interpretation of the data that we got back.
Which gives you a great level of credibility.
That's exactly right. So we went out into the field and collected the rock samples, brought them back into our laboratory and sliced them up and ground them up, and then separated the various elements in them. Turns out that rocks have minerals embedded in them. In fact, the rock that we were dealing with most in this project was granite. You're familiar with granite. It's kind of a white-looking rock with black specks in it. The black specks are what's called biotite. It's a type of mica. It's kind of a little shiny surface on it. And these little zircon crystals are what we were dealing with. But we had to separate them out, so we broke the rock into pieces with a big hammer and in an iron pestle and mortar here, ground them all up as fine as we could get, and then separated the minerals in them. And you could either separate them by sifting them through a sieve, or you could pick them out under a microscope with the tweezers, which is really tedious, or you could put them in a liquid that's very heavy, not water. Water has a relatively low density, and some of these minerals are 3 or 4 times as dense as water, so we had to have liquids that were very, very dense, and then the lighter minerals would float to the top and the heavier ones would sink to the bottom. We were able to separate minerals that way and then filter them out. So we did quite a bit of that in our laboratory and then sent them off to the general laboratory to do the experiment. And one of the main things we were doing with the helium diffusion experiment was finding out how much helium were in these rocks and how fast that helium was escaping out of the rock. For example, if you have children, they've had helium-filled balloons and they tie the balloon onto the end of their bed at night, they wake up the next morning and the helium has escaped out of the rubber in the balloon and the balloon is kind of collapsing down on the floor.
Right.
The same thing happens to rocks, but it goes on much more slowly. The helium will actually escape out of these. Now, the bottom line result we found from these experiments, I'll just state this up front and then we'll talk a little bit more about it, was that the helium diffusion work we did indicated that the 1.5 billion years, the equivalent of 1.5 billion years of radioactive decay, nuclear decay actually occurred between 4,000 and 8,000 years ago. In other words, we think that this process started, much of the helium is still in the rocks, but it's been going on for, the best estimate, 6,000 years.
Yeah.
That is the number we believe from a literal understanding of Scripture when God created the earth. Well, let me tell you a little bit more about the inside part of the granite. Inside the granite rock itself is these biotite flakes, and in the biotite is these little zircon crystals that you'll see here. These zircon crystals are very, very small. You really can't see them. They're on the order of 100 microns or so, which is about the diameter of a hair on your head.
Mercy.
And in these little zircon crystals, embedded in the granite, is the uranium and thorium, which is radioactive. So the little crystal is kind of like a little capsule of radioactive material. The uranium is decaying. It decays and produces lead within that zircon crystal, and the helium is in there, and the helium has to escape out of that zircon crystal. These zircon crystals don't melt except at very high temperatures, and they can actually go through a volcano and not be melted. The magma, all the rock around them can melt, and the zircons are still there, so it can go through a lot of earth processes and still be maintained. Here's a picture of some of these in a little bit closer detail. This is the kind of crystals, they take various sizes and shapes, but basically they're on the order of 100 microns. I said very, very small, and they tend to have facets on them. Here's one of these crystals, and you can see it has little flat surfaces on it. Very, very interesting featured type crystal. Down here's a graph that shows how uranium decays into lead. The uranium that we find in our zircons starts off, and it starts as a uranium-238 atom, and it results in lead, but it also produces helium along the way. There's a decay chain of a whole bunch of nuclear processes that start between its uranium turning into lead, and in the process it produces 8 helium atoms. Actually, it produces alpha particles. Now, these alpha particles are the core of a helium atom. It's got 2 neutrons and 2 protons with no electrons, and it shoots out in all directions, and as it goes throughout the crystal it produces damage in the crystal and then picks up electrons and becomes a helium atom. So the helium is trapped in that crystal after it's decayed. Here's an atom of uranium with all the electrons running around it, and it shoots out these alpha particles. There's 2 neutrons and 2 protons, and then it collects electrons and becomes a helium. That continues to do that. All throughout the life of the crystal, it produces all this product. If you take a rock as a whole, you can see this process going on, and it's actually kicking out helium. Now here's your alpha particles with the electrons around them. Those are helium atoms. So the rock is actually pressing out, or the helium is escaping out of the rock in all directions, but it takes a fairly sizable amount of time for that to occur. If it turns out if the rocks were 1 billion years old or so, all that helium would have already escaped. And when we went and collected the rocks, we found that the helium is still in the rocks, and we sent the rock samples to the lab to find out how fast it's escaping, and we were able to actually calculate the age of the Earth from how much helium is there and how fast it's escaping.
If they were really old, there wouldn't be any helium there at all.
That's right.
Okay.
But we found up to 50% of the helium that's decayed still in those rocks.
Still there. And that's a new finding, isn't it?
That's a brand new finding, and it's very controversial. We've presented this to the scientific community already, and they are astounded by it, and they're really scratching their heads over this.
You haven't really had a lot of response other than,
Well, that's right. We presented this to the American Geophysical Union meeting in San Francisco in 2003, and we had about 400 specialists in this field come by and talk to us. They were really puzzled by it, and they've gone back to their labs, and some of them are working on this problem themselves now.
But it's really important that we point out that they're not doubting that the helium is there. They're trying to figure out the significance of it. Isn't that right?
Yes, and how it's... Well,
that's
actually,
a very different question. Absolutely, we're positive the helium's there.
There's no question about that, and
Yes.
we're going to talk about that a little bit more after the break.
Okay.
But what's really puzzling them, they've spent most of their career looking at the lead, not at the helium.
Yeah, right, that's right. And the dating has always been based on the lead instead of the helium.
That's exactly right.
But they're telling us 2 entirely different stories. The lead would give you one date and the helium an entirely different date.
That's right. The lead gives you a date of about a 1.5 billion years, 1.5 billion years, and the helium, it turns out it's on the order of thousands. That's why we called it one of our books, Thousands, Not Billions.
Now we've got to take a break, and when we come back, we're going to have to deal with this dichotomy of results and how we justify that, or how we explain it, or what we think's going on. We'll be right back. You won't want to miss the conclusion. Stay with us.
Creation versus evolution. You weigh the evidence. A global flood, evidence pours in. 20th century geologists taught the familiar maxim, the present is the key to the past. But now that catastrophic processes are widely used to describe the strata record, 21st century geologists are discovering that marine flood sedimentation is the key to the past. Geological strata and their marine fossils provide critical evidence that the oceans once covered the entire planet. Widespread strata blankets are leading geologists to construct a global flood model for Earth history. Today's guest on Origins, Dr. Larry Vardiman, is chairman of the Department of Astrogeophysics at the Institute for Creation Research's Graduate School. Through his ongoing research in atmospheric science, Dr. Vardiman has contributed much to the field of creation science. He also led the RATE team, a research project examining the age of the Earth. This has been documented in the DVD, Thousands, Not Billions. For more information, contact the Institute for Creation Research, 1806 Royal Lane, Dallas, Texas, 75229, or call 1-800-337-0375, or visit the website, www.icr.org.
We're back with Dr. Larry Vardiman, and we're talking about the discoveries by the RATE group, and today we're talking about the helium that we're discovering in rocks, and this was something new and kind of earth-shattering to the scientific community. You have a chart there, Dr. Vardiman. Help us understand what that's about.
Well, I want to tell you a little bit more about the samples that we used to come to the conclusions we did. We obtained a core of granite from a drilling that was done in New Mexico by the Los Alamos National Laboratories. They were looking for geothermal sites, looking for steam that they could use to produce energy. And in this core, the site, they pulled out a core all the way down to over 12,000 feet down in the ground. And we had access to those cores and were able to sample them for the zircons in them. And in those zircons, look for the amount of helium. This table that you see here had samples from the top. Sample number 1 is near the top in meters. That's about 1,000 meters, which would be about 3,000 feet down in the ground, at a temperature of a little over 100 degrees centigrade, which is about the boiling point of water. And in that sample, we found that 58% of the helium was still there in the zircons that would have been released in 1.5 billion years, the equivalent of 1.5 billion years of decay. Now, it changed as we went down in the core, all the way down to almost 4,000 meters down, which is about 12,000 feet down in the rock. We found a temperature almost 300 degrees centigrade, much, much hotter, and there was only 0.1% of the amount of helium left there. Now, the reason for that is the hotter the rock is, the faster the helium is going to escape out. And there's physical laws that determine that. But the surprise to us was how much helium was still in the rocks at the colder temperatures. We then took this and put it into a graph that looks like the following. And now this is a bit of a busy graph, so let me describe it in a little bit of detail. The vertical axis is what's called diffusivity, and this was determined from the rock samples that we had by taking the amount of helium we found in the rock and calculating over what period of time we assumed that this helium had diffused out of the rock and how much was still there, and plotted that. The horizontal axis on this graph is temperature. Now, it's plotted backwards from what you would normally think of. The cold temperature is to the right, and the warm temperature is to the left. Now, up at the near the top, we plotted some data that we obtained from the core as a function of temperature, and we found that the measurement in the blue dots that you see there indicate that this would be the relationship between how much helium would diffuse, how fast it would diffuse. The diffusivity on the left side of the graph there is a measure of how fast it diffuses out. And that's a logarithmic scale, by the way. It's not linear, so it goes up exponentially. It's a very, very rapidly increasing value. But we plotted that data, and then we put on that same graph an estimate if it had happened in 1.5 billion years and a 6,000 year period of time, what we would expect it to do. And
that's the two models.
That's the two models you see there. At the bottom is the uniformitarian model, which was the 1.5 billion years. That meant if the helium that we find in the rocks was diffused over that 1.5 billion years, it would have to be a very, very slow rate of escape or diffusion.
Right.
And therefore, it's down near the bottom of the graph. If it happened over 6,000 years, which is our creation model, then it would happen a lot faster. We put that data on there, the first set of data, and put the model together and reported that in our first report, saying this is what we would expect the difference to be. When we sent the data off to the lab to actually get the measured diffusion rates, we then plotted this on the graph after we had projected what it would be, and the blue dots are what showed up on the line there, and it matched up with the creation model.
So the data perfectly fits the creation model. I don't see any blue dots down there in the uniformitarian
That's
model.
right, and there's over 100,000 times difference between those two models. So
The difference between billions and thousands.
that's exactly
Sure.
right. And we anticipated that we would have the model be confirmed by the data we went out to the field to get, but we said this ahead of time. This is one of the things you do in science. You make a prediction,
Yes.
and then when you collect the data and compare it with your prediction, or a hypothesis as
Yes,
we called
that's
it,
right.
it fit the creation model right to a T.
That had to be really exciting.
Oh, our scientist, Dr. Russell Humphreys, who did this work, was just astounded. In his 30 or 40 years of research, he had never had the data come out that close to his prediction. He was just thrilled with it.
Would you use the word irrefutable with this?
I think so. I mean, it's incredible that it came out so well. Now, there's obviously going to be some criticism of this. People have had different ideas as to why that would be. In fact, we've had probably 6 different attempts to refute this, and Dr. Humphreys has been successful in turning all those criticisms aside.
That's exciting.
So it's really come out well. Now, we were able to turn that data around also, and since what we were doing was measuring diffusivity and measuring how much helium was actually there, if you turn the equation around, you can project what the age of the Earth actually is. And we came out with an estimate of 6,000 plus or minus 2,000 years.
And I like the way you guys say it. It's thousands versus billions. And so, you know, we're not going to quibble over 1,000 years. We're seeing two
Right.
whole different worldviews that are represented here, and the evidence is supporting the creation model. I think that's so exciting.
Now, maybe it'll help our viewers to be able to see the difference here between this long age idea of billions of years and thousands of years by taking two sundials. On the left, we have the nuclear decay sundial that would result in 1.5 billion years. And up on the top of this clock is uranium decaying into lead. And there's a little lever there, it was highlighted, that basically we believe God turned the lever on this during the Genesis flood. Over on the right is helium. When the uranium is decaying, it produces both lead and helium. You'll notice that it connects to the right sundial, and the helium is being put into the second sundial, and it's accumulated in the upper part of that like it's accumulated in the zircons. During the time that there was accelerated decay, which we think happened during the Genesis flood, there was a lot of lead produced and a lot of helium produced. And then at the end of the Genesis flood, when the accelerated decay was shut off, God kind of turned that dial and it slowed down to the rate that we have today. But yet the helium had accumulated during that period of time in the zircons in granites. Although today the decay rate of uranium into lead is very slow, the helium is still there slowly leaking out of the zircons, and we believe that that is a preferred method of estimating the age of the Earth.
Accelerated decay, I have a feeling, is going to become a very pertinent term in the origins debate in the years ahead.
I believe you're right. The uranium lead clock gave 1.5 billion years, and the helium clock gives us 6,000 years. So the two clocks were going on at the same time. We've just been looking at the wrong clock.
We've been looking at the wrong clock. I'm going to read this sentence again from the introduction of the Book of Conclusions. This is Volume 2 of Radioisotopes in the Age of the Earth, the report of the Rate Committee. And in the introduction, the final paragraph begins with this sentence. This book opens a new chapter in the origins controversy. Friends, there is going to be pushback on this. There are going to be evolutionists who are going to try to refute this exciting scientific finding by the RATE team. But I believe that God has kind of thrown a curveball here that is going to make this debate a whole new debate on a whole new playing field in the years ahead. Dr. Vardiman, you have given us a great service, you and your team, and we're so grateful. And I'm so grateful that you've been here to share it with our folks on Origins. So always remember that it's God's view He created you, and that should be your worldview too. Until next time, I hope you'll ponder this incredible stuff that we've learned today on Origins.
Thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 813 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins Program number 813, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.
Hello folks, welcome to Origins. My name's Don Chapman. It's my privilege to be your host. Origins is a forum where we use the evidence of science to validate the truth of creation. We have a gentleman with us who has helped to dig up some of that scientific evidence that I think is really exciting because it affirms a young Earth as the Bible does. Dr. Larry Vardiman is here with us. Dr. Vardiman, good to have you.
Glad to be here, Don.
Now, you are the coordinator of the RATE group.
Right. The RATE project is Radioisotopes in the Age of the Earth, and I was kind of the organizer of it and the administrator.
And you had three big conclusions from that.
Right. The conclusions basically revolved around helium diffusion out of zircons in granite, and radio halos, polonium radio halos, and the carbon-14 in coal and diamonds.
Now, of those three things, we're doing a show on each of those. Today we're going to zero in on the halos.
That's right.
Who would have thought we'd be talking about halos? Yours looks nice and straight. How's mine?
You're looking good.
Okay. We're talking about thousands, not billions of years. Your evidence is really challenging what you guys call one of the icons of evolution.
That's right. The long age of the Earth, the billions of years of age for the Earth, is just automatically assumed by the conventional scientific community and our world around us. So it's one of those things that has become an icon of evolution.
There can't be evolution without billions of years. Even to any person, the most avid evolutionist, if you could prove that we didn't have billions of years, evolution's done.
That's right. Evolution is impossible anyway, but most people think it can happen if you got enough time. But if you take away the time aspect, evolution would be understood to not be able to be possible.
And your group's study came up with 3 things that you think affirm a young Earth and take away that time.
That's exactly right.
And tell us now, the one we want to zero in today is halos. I think that most of our folks don't understand what they are and what they do, so we really need you to teach us.
Right. We're dealing with this issue of thousands of years, which is what the Bible teaches, versus the billions of years that conventional science basically assumes. And in doing that, one of the main pieces of evidence we came up with was the issue of radio halos, and in particular polonium radio halos. These are small damaged spots in rock that is produced by the decay of uranium or other radioactive material as it decays to its daughter products. Uranium is the parent product, and it decays into lead and helium, which are the daughter products. And in doing that, it has a whole decay chain along the way, and each time it throws out an alpha particle, which was part of the decay process, it damages the material and leaves evidences.
And when you slice through the rock, even though it's actually a elongated thing, but when you slice through it, it gives the appearance of being a little halo.
That's right. The radioactive material is embedded in granite. Granite is a kind of a white rock with black specks on it. Most everybody's seen it. You go out and pick them up. The little black specks are biotite. It's a kind of a mica, and it peels off. It comes off in layers. Inside of that biotite are little zircons. Now, these are little crystals of zirconium silicate. These little crystals have embedded in them uranium and thorium, which are radioactive. And they throw out these alpha particles as they're decaying to the lead and helium. Those alpha particles spew out in all directions, produce a sphere of damage in the rock, kind of discolorated. If you peel off the mica, you can actually slice through that at different layers, and it forms a ring in that little thin layer of mica that you peeled off, and if you look at it under a microscope, it looks like a ring or what we call a halo.
Very good.
And some of the particular ones that we're going to talk about today are polonium radio halos. I might just mention to the young people in the audience that are kind of interested in this, you can actually do this kind of work at home. If you take a piece of granite and you find those black specks on it, and you take a piece of tape, put it on the black speck and peel it off, you'll peel off a few of those little layers of mica. And if you take that then and put it on a microscope slide and put it under a microscope and search around, you'll start finding these little round halos in there. And so our young people quite often enjoy doing that.
Well, I bet some of our homeschoolers will be trying that out soon. Why don't you go to the screen and show us the material you have for us on the halos today.
Okay. We went out in the field to collect samples, and we were collecting granite. We were working primarily with granite in this whole effort. And we collected granite samples from all around the world to be able to have a wide distribution of samples. This is particularly one that maybe some people in the southeastern United States would be familiar with. This is Stone Mountain near Atlanta, and it's made out of granite. Oh, okay. So we collected a whole series of granite samples across the top of Stone Mountain. We collected granite from the White Mountains up in New Hampshire. We collected granite from the rocky outcrops in Southern California and in Australia. Dr. Andrew Snelling, who did most of this work on this project, is from Australia, and he collected a number of samples from Australia. My favorite spot for collecting samples, however, was in Yosemite National Park. And this is Dr. Snelling sitting up above the canyon there, the Yosemite Valley in Yosemite National Park. And I mistakenly accompanied him on this rock collecting expedition, which I would advise your viewers, don't ever become a helper to a geologist, because you end up getting carried all the rocks. You don't see him carrying any rocks.
He's very busy taking notes.
That's right.
Yeah.
Well, we started at the top of Glacier Point, in Yosemite National Park, and we hiked down a 6-mile trail down the south side of Yosemite Valley into the valley floor below, collecting rocks along the way. And by the time we got to the bottom, we had about 40 pounds of rocks that I was carrying on my backpack. So I was completely worn out by that. We collected a lot of other rock samples all the way across Yosemite National Park as well, so we have a very good collection of rock from Half Dome and other places. Now I need to tell our viewers that you can't just go into a national park and collect rocks or fossils or pieces of trees and stuff, take home. That's illegal. You can get arrested and you can get fined for it. We had a special collection permit. And even with the collection permit, as we were going down the trail, we had to not collect the samples when there were other people on the trail that could observe us. So it was kind of funny. We were out here in the woods, and Dr. Snelling was my lookout, or I was his lookout, I guess I should say. And we'd wait to make sure there wasn't anybody coming in any particular direction. Then he'd pound on a rock and break off a sample, and we'd stick it in the bag and then continue on down the trail.
Made you look guilty even though you weren't, right?
Right. We had to do it that way because quite often people would get upset, you know, seeing people taking rocks out of the park if they knew the rules.
But you had all the right permits.
That's right. Well, now here's what a polonium halo looks like, or a halo. And these are a little difficult to visualize here, but each one of these are halos, and some of them can be produced by uranium and thorium and polonium or any radioactive material that would be in the rock. These particular ones are polonium halos. The one on the upper left are uranium halos, and you can tell the difference by them by the number of rings that they have. And they're a little bit fuzzy, but after you've gotten experienced with this, you can begin to tell by the size and the number of rings in the halo which element it has. Each element puts out a different number of rings, so it's kind of like a fingerprint. You can actually identify what kind of an element it is. Now, the interesting thing about these halos is that it takes millions of alpha particles that are emitted from the uranium center or the polonium center or the thorium to produce that damage and to be able to see a visualized ring. But the polonium halo, for example, only has a half-life at most of a few weeks. And in some cases, the different isotopes of polonium have half-lives less than a second.
Oh my.
So it disappears very rapidly. And that's why this is so significant in terms of estimating how long the decay process occurred. It had to happen very, very rapidly. And it had to happen with a lot of decay in a hurry under conditions where it was solid rock and the rock was cool enough. Because if this occurred in magma, the halos won't form because it just gets all distorted. If it's in rock that is too hot, the halos will actually kind of dissolve and go away. So if the rock is 150 degrees centigrade, which is just a little over the boiling point of water, or cooler, then the radiohalos will remain and you can count them. But if that means if it had to happen under those kind of conditions very rapidly, that means that the process had to happen extremely fast, much faster than we observe it today.
So something drastic was happening quickly.
That's right. Now my next diagram here actually will show an animation of this. This is a zircon, kind of a graphic demonstration of a zircon. The alpha particles are coming out in all directions, and they are producing damage in the surrounding biotite. The black surrounding would be like the biotite, and you can see this coloration showing up here. And it shows up in actually a sphere. We're looking at the sphere, and now if you slice through that, you get the rings like we saw in the previous diagram.
Gotcha.
Okay? That's how that process occurs. Now, if you do this actually in a granite rock sample, here's what granite looks like. And we're going to home in on the biotite. And then within the biotite is the zircon producing this damage. It turns out in the process of uranium decaying, it produces polonium. And this polonium itself is radioactive and produces little radiohalos away from the uranium radiohalo. Now, the question is, if the polonium radiohalos have such a short half-life and have to emit a tremendous amount of radiation, alpha particles, in such a short period of time, and yet they're at a distance away from the uranium source, its uranium halo, how did that happen so quickly? It had to be very unique conditions. The rock had to have been formed, there had to have been a flow of fluid through the rock to move those little polonium halos a certain distance away from the uranium. Then the polonium had to decay very rapidly to form the halos, and that had to happen all very, very, very rapidly.
Go over those three things again.
Okay, you had the uranium decaying, producing polonium, which had to be moved away from the uranium by hydrothermal fluid moving through the rock, and then it formed another polonium radiohalo at a distance away from the uranium. That whole process had to happen extremely rapidly, and we feel that this is direct, straightforward evidence of accelerated decay. That's why this is so important.
And you know, when you mention the water, it makes me wonder, are you thinking of a historical event when this would have happened?
Yes, we believe that this actually happened during the Genesis flood.
Sure.
That there was a tremendous amount of heat, there was a tremendous upheaval, the formation of granites all around the globe, and that these also had water flowing through them associated with the flood and the movement of water through rocks. And then the sudden cooling, it had to go from a magma to solid rock to cool rock with fluid through it in a matter of less than a year.
Yeah.
And this whole process would have allowed polonium radiohalos to occur.
That's fascinating.
Now, I need to say that the one who did a lot of analysis on it was a fellow by the name of Dr. Robert Gentry. And he believed that this was a signature of God's creative event at creation. And we believe that too, that these were formed at creation. But we now have evidence that this occurred during the Genesis flood as well. And we'll talk about that in the next slide here. So there was actually two events that we now have very good evidence for, that God intervened directly in the affairs of the earth, the geology of the earth, to produce these catastrophic processes supernaturally, both at the creation and at the flood. And of course, he's intervened in other places according to the scripture as well. But we have direct evidence here now, seeing almost the fingerprint of God, as Dr. Gentry called his book about this.
The fingerprint of God.
Yes.
Yeah. Doesn't just happen in everyday circumstances.
No, it doesn't happen today.
Yes.
It can happen in very limited locations under extreme conditions, but it doesn't happen globally like we have evidence for here.
Right.
The next slide here allows us to try to identify this with the flood a little bit, these productions of radiohalos. This is a diagram on the left. You see the vertical scale here that shows the number of radiohalos per slide that we took. In other words, you take this tape that has the little mica on it and you put it under your microscope and you find the number of radiohalos per slide, the number of those from 0 up to over 60. Along the bottom is the conventional age scale in millions of years, all the way from 0 to 3,000 million years. That's 3 billion years in conventional time. And we found, with the rocks dated according to conventional time scales, we found polonium radiohalos in all those rocks, but we found a peak in that occurrence at about 300 to 400 million years ago, according to the conventional scale. Well, it turns out those rocks that are dated conventionally at about 300 or 400 million years ago are at the bottom of the sedimentary layer. That is, the layers that were laid down by the flood. Okay. If you go to Grand Canyon, you look over the edge, you see all these layers across Grand Canyon. Those have been laid down by the flood. At the bottom of that layer are the rocks that have this kind of an age, 300 to 400 million years. And that's where the peak in the number of polonium radiohalos occurred. So we identify this process with the flood. That's why we believe that this occurred at the time of the flood as well.
Now, just so our people understand, you don't really believe that was 400 million years ago. You're just using their scale to give you these layers to show where it was.
Right. We have to be able to use the language of the conventional community to talk with the conventional scientists, plus among ourselves as well. We have some alternative methods and tables that we look at it, but we use their time frame and their terminology in order to be able to talk the same language.
Dr. Vardiman, we have to take a break, but when we come back, I want to discuss with you the significance of these discoveries. We'll be right back. Don't you go away.
Creation versus evolution. You weigh the evidence. The fossil record, a rapid burial. The Earth is covered with layers of sedimentary rock, much of it containing microscopic fossils such as plankton, pollen, and spores. The visible fossil record consists mainly of marine creatures, including clams, jellyfish, and coral. They are found primarily on continents and mountains, rarely in deep ocean basins. The fossil record is strong evidence for the sudden appearance of life by creation, followed by rapid burial during a global flood. Today's guest on Origins, Dr. Larry Vardiman, is chairman of the Department of Astrogeophysics at the Institute for Creation Research's Graduate School. Through his ongoing research in atmospheric science, Dr. Vardiman has contributed much to the field of creation science. He also led the RATE team, a research project examining the age of the Earth. This has been documented in the DVD Thousands Not Billions. For more information, contact the Institute for Creation Research, 1806 Royal Lane, Dallas, Texas 75229, or call 1-800-337-0375, or visit the website www.icr.org.
We're back with Dr. Vardiman talking about halos that are found in rock, and the significance that they hold to the young Earth. So, Dr. Vardiman, do I hear you saying that these polonium halos show that there is accelerated decay?
Yes, they're direct evidence for accelerated decay, very much like the helium that we found still resident in the zircons. That's a kind of a smoking gun, you might say. And so is the carbon-14 that we're going to talk about in another program. That's direct evidence that's still existent in the rock, that there was a lot of decay and it happened a short time ago. The same thing with polonium halos. We're actually able to go a little further with polonium halos, and because they had such a short half-life, they had to have happened very rapidly, and because they are at a distance away from their parent, which is the uranium halos, they had to have moved there, and that had to have happened in order of milliseconds and at most a few weeks. And for the rock to cool down from magma, because granite comes from a molten rock, to cool down to become a solid rock and to cool below 150 degrees so that the halos will remain, that all had to happen in a very short period of time. That talks about processes that happen much more energetically and faster than anything we observe today. And that's one of the strongest bases for accelerated decay, as we call it.
And you're saying that the one time in the history of the world when the climate and when everything was just right to do that was the worldwide flood?
Right. I believe that it happened not only at the flood, it also happened in creation, because that was a special circumstance that God had his hand directly on it and was causing supernatural process. But it also happened during the flood. Now, if Noah and his family hadn't been protected from all that was going on the rocks of the earth by all that water covering it, they would have been probably irradiated by all this that was going on.
So underneath the water there was incredible heat.
Incredible amounts of heat, catastrophic processes, mountain building, separation of continents, and accelerated decay. All of this was going on. It was really dynamic.
Yeah, we just think of the water going up, but there's a whole lot more going on than that.
Now, this accelerated decay is very controversial, and it's hard for all of us to really grasp the implications of that. We presented this information to a science conference in San Francisco in 2003 at the American Geophysical Union, and we had a number of specialists, they're called geochronologists, who came by and discussed this with us, and they were basically amazed at what we had. They were complimentary in the quality of the research that they were seeing and encouraged us to do more of it, but they couldn't explain it. They didn't want to accept our explanation of accelerated decay by God's direct intervention. It has to all be naturalistic from a scientist, conventional scientist perspective, but they couldn't explain it another way.
So we're kind of at the beginning. Again, we've kind of opened a new playing field in the whole debate, haven't we?
That's right. This is a whole new approach to things, and it's really exciting.
And obviously, at some point, the evolutionists are going to have to deal with this evidence. They can't just ignore it forever, can they?
No, I don't think they can. In fact, I don't think they are. We've had evidence that there are a number of scientists, some of which were at that meeting in San Francisco, who are now doing this kind of research in their own labs, trying to figure out what we've discovered and try to explain it in another way. I know, for example, that the National Science Foundation is now funding research on accelerated decay. So it's really exciting.
And there's a pragmatic reason for that, too, isn't there? It just isn't for this debate, but there's a desire that folks would have in finding out if we could cause accelerated decay, isn't there?
Right. Many of these proposals that are funded by the National Science Foundation have at their basis a method for trying to be able to get rid of nuclear waste. If you have radioactive material and you can speed up the process, you don't want to speed it up so it explodes like a bomb, but speed it up, you can get rid of it a lot faster and you don't have to store it for thousands of years. So there's a real a monetary reason for doing this kind of research as well.
Isn't that exciting? Wouldn't it be something that because we were doing research, your research kicks off spending of millions and millions of dollars. I don't talk about billions and billions of years, but I do. I've been around the government long enough to talk about millions and millions of dollars. That research to get rid of nuclear waste would validate the theory that of a young Earth. Wouldn't that be wonderful?
That is great. In fact, we don't have the resources, either manpower-wise or financially, to do the kind of research that is done in the conventional community. So we rely a lot on research that other scientists who are doing that are not creationists, but we use their research results, and at this point we're excited about seeing some of them base some of their research on the findings that we've had.
That's tremendous. This is exciting. Now listen, if folks want to know more about this, you have a couple of books, one at the academic level and one at more the layman level. Will you tell us about those?
Right. Our premier book is the technical book called Radioisotopes in the Age of the Earth. It's about an 800-page textbook. You have a copy of it there, Don.
It's a heavy book.
It weighs about 2 pounds. We call it our doorstop.
It's a great book.
At any rate, this is a book that's appropriate for a scientist or someone who has a very strong technical background. I would encourage many people to purchase it, but it's for the scientist type. There is also another book that we've done. It's a paperback, about 200 pages in volume, called Thousands, Not Billions, and it's written for the general public. Now, you still have to have a little bit of technical background, but it allows a person who doesn't have all that training to at least get the basic ideas down and to be able to understand it a little bit more than they would otherwise.
Dr. Vardiman, I again want to thank you for having the foresight and the vision to pull together this group of eminent scientists who gave 8 years of their life to the study that has brought these 3 dynamic conclusions which are really transforming the whole date of the Earth debate. You've given us a great service. We're very, very grateful. And I'm excited to see what God's going to do.
We're grateful to God for providing it for us.
Folks, I bet today, after hearing this show, when you hear the word halo, it's going to have a whole different image for you than it's ever had. It's not the halos in the outfield, it's the halos in the rocks that validate that we have a young Earth that God made. Don't be swayed by the evolutionists who want to just say there's billions of years because we said so. God has said He made a young Earth, and He made it for us because He loved us. We always remember it's God's view that He created you, and that should be your worldview too. So God bless you till you're with us next time.
Watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 814 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins program number 814, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.
Hello, my friends, and welcome to Origins. My name is Don Chapman. It's my privilege to be your host. Origins is a forum where we take the evidence of science, we use it to validate the truth of creation. We're in the midst of a series of shows talking about the work of the RATE group, and Dr. Larry Vardiman is here, and he is the gentleman who coordinated the work of these eminent Christian creation scientists who pulled together their work to work on the age of the Earth.
Right. The RATE project is Radioisotopes in the Age of the Earth, and I was kind of the organizer of it and the administrator.
So you pulled together these eight really A-team players from creation science.
That's
and,
right.
And you worked for 8 years together. And you came up with 3 incredible conclusions that seem to indicate a young Earth. Would you list those for us?
Sure. We've talked about helium diffusion in a previous program. We've talked about polonium radio halos. And today we're going to talk about carbon-14 and coal and diamonds. And these are just 3 premier examples of accelerated decay and evidence for a young Earth.
I think this term accelerated decay is going to be to the next 10 years what perhaps irreducible complexity was to the last 10 years in this whole debate.
I hope so, even more.
I think that's really exciting. Well, today we're going to talk about carbon-14 dating. Now, I think for most of our folks, people think that carbon-14 is what's used to date everything, but it's not really what's always used in this whole dating scheme, is it?
No, carbon-14 is used for dating organisms that have died or some type of a life process. Carbon-14 has a half-life. That means half of the radioactive material in it has died away within 5,700 years. So only a few lifetimes, it's all gone. Whereas to date rocks, you have to use such things as uranium, lead, or rubidium, strontium, other long-period half-life materials if you're going to date rocks.
So, but carbon-14 then, if we're studying rocks in the age of the Earth, how does that come into play?
Well, carbon-14 relates specifically to fossils and wood and anything that was alive in the past, which we want to get some handle on when it died and how long it's been around on the Earth.
But you're going to apply this to rocks, aren't you? Particularly to coal and diamonds. I'm kind of giving away the story
Right.
here, but
Coal and diamonds are a type of rock, but they have carbon in them.
Yes.
And particularly coal is made up of a material that was compressed, I believe, during the flood. And so we can actually get an estimate of when the flood occurred based upon how old the coal is.
well, we're anxious to see what you have to share with us today because I think this is a program that has evidence that's almost irrefutable.
One of the first things that we like to talk about is bones. This is a picture from the National Dinosaur Museum in Utah, Vernal, Utah, and we can actually try to date those directly by doing carbon-14 techniques on them. Another thing that we can do is coal, but this hasn't been really addressed very much, at least in the conventional literature, because it's assumed that coal is like 100 million years old. And since carbon-14 has a half-life of about 5,000, almost 6,000 years, if coal is really 100 million years old, you wouldn't expect to find any carbon-14 at all in it.
0, that's right.
0. In fact, the bones that we showed in the previous slide, the dinosaur bones, those are assumed to be 65 million years old or older, so you wouldn't expect to find any carbon-14 in them either. But we're going to talk about that a little bit here because, in fact, we have been finding carbon-14 in these, surprisingly. There is a new instrument that has been developed. It's called an accelerator mass spectrometer. And this was developed about 15 years ago, or a little bit more now. Prior to that, the instrumentation that was used to try to measure carbon-14 in objects, any kind of material, didn't have the precision to be able to find the small amounts of carbon-14 that are still present in coal and dinosaur bones, for example. But about 15 years ago, this instrument was developed, and unbeknownst to us, when we started the RATE project, there was reports already occurring in the conventional literature. So after we started our RATE project, we were informed of this, and we added this effort to our program because it was so significant. And in fact, there was some 70 papers that were present in the literature reporting on carbon-14 in coal. Now, we were completely surprised by this. We didn't know it had been done. And the question is, if there were so many papers in the literature, why hasn't this been widely known and accepted?
So before this machine, we didn't have an instrument precise enough to measure the carbon-14 in coal. Is that right?
That's right. There had been a few creationists who had tried to develop equipment to do that, but it just wasn't precise enough to measure those small quantities.
And the results of this instrument are accepted across the board by all scientists?
Yes, and the reason actually that it's reported so widely in the literature is when they first began to get measurements of carbon-14 in coal, they were scratching their heads and saying this can't be because the coal is too old for there to be any there. Where did it come from? So they assumed it either had to be contamination of the coal, carbon-14 from the atmosphere had gotten into the coal somehow and continued to do so, or their instrumentation, their instrument itself was somehow being contaminated. So they kept reporting on it and refining their instrumentation. A little bit of it was due to that, but they finally eliminated all those possibilities and they were still getting the carbon-14 in the coal.
That's exciting. So you made that a part of your project?
Yes, when we discovered this, we included that as a major part of our project, and the end result of this was a significant evidence for a young Earth, we felt.
Okay.
Okay, well that was the instrumentation that we had. Let me tell you a little bit about where the carbon-14 comes from in the atmosphere. Cosmic radiation comes in from outer space and strikes nitrogen-14. And it converts it to carbon-14. One of the atoms becomes carbon-14 and it's distributed among all the other gases in the atmosphere. The assumption in carbon-14 dating is that that has been going on ever since the Earth has been here, and at the same rate, so that the amount of carbon-14 is uniform in our atmosphere. That's a major assumption of this process. Now it turns out I don't believe that that was the case, but it's still the technique that we have to address. There's also this carbon-14 that has been produced by cosmic radiation is then incorporated into living organisms. For example, plants, cows and other animals that eat the plants, other animals like mankind that eats the cows. Embedded in those living organisms is the same balance of carbon-14 and carbon-12 that is present in the atmosphere. When that organism dies, it's no longer incorporating any carbon-14 from the atmosphere, and what's in the organism then decays. And so by measuring the amount of carbon-14 and the carbon-12 in the organism, you can estimate how long it's been dead, how long ago that organism died, whether it's an animal, whether it's a plant, a tree, or a dinosaur, whatever. So you can get an estimate. Now, it's based on the assumption that the carbon-14 and carbon-12 ratio in the atmosphere has always been the same. And as I say, I don't believe that was the case, but that's the technique. Now, how does this apply to trying to estimate, for example, the age of coal and maybe the age of how long ago it's been since the flood? This is an animation showing the carbon-14 and the carbon-12 in the atmosphere being incorporated in a tree, for example. This tree then suddenly being buried by the flood, and all this organic material being buried, grasses and trees and ferns and all that material, into a layer compressed by heavy pressure, forming coal, and then within that coal is that same carbon-12 and carbon-14 that was in the tree to start with, but it was suddenly buried and killed, and then the carbon-14 decays into carbon-12, and you can estimate how long that coal has been around. So if we were to date it using the conventional technique, we would expect, if the flood only happened, say, 4,000 or 5,000 years ago, you would expect to still find some carbon-14.
But if it happened millions of years ago, there wouldn't be any carbon-14.
That's right. If it happened 100 million years ago, which is the standard expectation for a coal layer, it's that old, you wouldn't expect to find any carbon-14 at all. So what happens when you go to the field and collect coal samples and analyze it in this new equipment that has this precise ability to measure carbon-14? It estimates the coal to be about 50,000 years old.
50,000 years old?
50,000, not 100 million years old, but about 50,000 years old.
Okay.
Now, the first thing we had to do was to confirm that this kind of information made sense in the literature. So we went to the literature and got the data, and we plotted it. There was some 70 sets of data that had been reported. We have this all listed in our book that we reported on the RATE project. Here we have the number of samples on the left column, And on the bottom axis, we have the percent of carbon-14 in the sample relative to the modern carbon-14. That's a little bit of a complex measure there. But it comes out that the ratio of carbon-14 to carbon-12 is what that second C is there, that it comes out to about 0.3. And so that's about the middle of this diagram here, this histogram. And that's much more than we would have anticipated if the coal is old. This is all for coal. But we went further than that. We actually then took samples ourselves, and we didn't have the money to go out and get 70 samples like is reported in the literature, but we wanted just to get a sample. So we went to the Pennsylvania State University coal lab and acquired 10 samples of different kinds of coal, all the way from the top of the formation of the crust of the earth to the bottom. There's different layers, so that you would expect them to be older or younger.
Right.
And this is the kind of samples that we got. Again, we came out with the same diagram, number of samples and the percent of modern carbon, and it came out to about 0.3. Here was about 0.25, somewhere in this neighborhood there. Very close to the larger sample that was reported in the general literature. Now, the significance of this, in addition, was because we had 10 samples of all kinds of coal, it turns out that the distribution is relatively narrow and doesn't show any change as a function of depth. In other words, you would expect there to be much less carbon-14 in coal that was down near the bottom, which was much older, and much more in the coal up near the top, which supposedly would be much younger.
Which assumes uniformitarianism, that gradually over millions of years these layers were put down.
Exactly, over
and that
millions
would mean
of
that
years.
the lowest ones would have the least carbon, if any, and the upper ones, if there was any carbon, it would be up there.
But they all had the same
But it's
amount.
the same right through, like it all happened all at once.
All at once. That
Yes.
gives you an indication that something
right.
dramatic happened very suddenly, all at one time.
Okay.
Okay, well, one of the criticisms for this technique is that possibly the coal has been contaminated. You remember I said all these 70 papers that had been published in the literature said that coal may have been contaminated, or their instrumentation had been contaminated. They eliminated the contamination in their instrumentation, but possibly the coal itself. Now, how that could happen is the coal is under the ground, and you could imagine groundwater percolating from the atmosphere.
Okay.
It'd have the carbon-14-12 ratio and going down through and percolating through the coal.
So the water could bring fresh
It
carbon.
potentially could
Yes.
do that. Now, we selected samples, and so did the conventional community, to minimize that, and it's not very likely, but theoretically it could happen. So Dr. John Baumgartner, who conducted this study for us for the RATE project, had an idea.
My part in the RATE project was to coordinate the research on carbon-14. What we found is like a bombshell as far as evolution is concerned. The essence of our work is that carbon-14 exists in all fossils throughout the geological record at levels easily detected by the current technology. And what this means is that all of these fossils are young. As far as we know, there may have been one or two attempts in the past to look for C14 in diamond, but the standard community, the secular community, would have no motivation. They would think it would be impossible for there to be C14 in diamonds. All of them we have tested thus far are from Africa, but from different parts of Africa, and we have diamonds both from deep mines and also from surface locations where they have been blasted out of the earth, come down, and gotten incorporated into streams and stream beds. So we have diamonds from a deeper earth environment as well as surface environment.
It took them about 2 years to do this experiment. This is kind of an interesting dilemma, because they had to crush the diamonds first, and then they had to take the particles, the fine flour from the diamond particles, and vaporize it in an oven in order to be able to run it through their the accelerator mass spectrometer. Well, the problem was these little bitty chunks of diamond, when they would heat them up to several hundreds of degrees, almost 1,000 degrees centigrade, they would explode. And the first time they did, they blew up their oven. And the guy who was doing this experiment for us under contract was so interested in it, he decided to buy him another oven and try again and break them up finer. Finally, he was able to get the diamonds crushed and vaporized and run the experiment, and guess what he found? He found carbon-14 in diamonds. Estimated that the diamonds were on the order of 50,000 years old as well.
Same as the coal.
Yeah.
Okay.
But diamonds are thought to be 1 billion or more years old. They come from way down in the crust of the earth, and they're thought to be billions of years old, not just 100 million, but 1 billion, 10 times older. And yet they had carbon-14 in them.
Now, the graphs that show them 1 billion years old is not based on any scientific evidence. That's based on assumption, isn't it?
It's based on a whole idea, a model, and so on. It's applied to it,
right,
but it's not a direct evidence.
Right.
Yeah, it's a model.
That's right. Well, we have to take a break, and when we come back, we're going to look at this diamond and the carbon in it, and we're going to look at the ramifications that this has to the whole debate of the age of the Earth. Don't you go away. We'll be right back.
Creation versus evolution. You weigh the evidence. Wonderful water, designed for life. Water. We drink it, wash in it, cook with it, and swim in it. Every system in our body uses it. The Earth could not support life without water. Water is 83% of our blood, flushes body wastes, lubricates joints, keeps our body temperature stable, and transports nutrients. Water is a part of cells which make up all living things. It is a very small molecule, but it's the biggest ingredient of our planet. Water has been designed just right by our Creator for life. Today's guest on Origins, Dr. Larry Vardiman, is chairman of the Department of Astrogeophysics at the Institute for Creation Research's Graduate School. Through his ongoing research in atmospheric science, Dr. Vardiman has contributed much to the field of creation science. He also led the RATE team, a research project examining the age of the Earth. This has been documented in the DVD Thousands, Not Billions. For more information, contact the Institute for Creation Research, 1806 Royal Lane, Dallas, Texas, 75229, or call 1-800-337-0375. Or visit the website, www.icr.org.
We're back from the break. We're here with Dr. Larry Vardiman, the coordinator of the RATE group, which did this incredible study. These creation scientists that came together to study the age of the Earth and found 3 incredible discoveries that have really transformed the whole debate about the age of the Earth. And we're talking today about carbon-14. Dr. Vardiman, you just showed us a chart that, according to what you're reading in coal, was about 50,000 years, and then when you got to diamonds, you had the same thing. Now, you have an animation for us about how that worked with the diamonds. We're anxious to see that.
Right. We found a similar result in diamonds, and this was a complete surprise. We weren't expecting it, but it's incredible. Here's an animation of what actually happens here. Diamond is the hardest substance known to man, and inside of it was originally carbon-14 and carbon-12, and then with time, it decays just like it would in coal, and it's not contaminated. It's so hard and so compact a capsule that even water running by it is not going to contaminate it. So whatever was incorporated in there was there to start with, and you couldn't add or remove anything. So if there's carbon-14 in there, you'd expect it to be very young if it's still there. In fact, that's what we found. We found the concentrations of carbon-14 in diamond a little bit less than coal, but it was about the same. It came out to around 30 to 40,000 years old, whereas coal we found to be about 50,000 years old. But the diamonds themselves are conventionally thought to be billions of years old.
So the difference between 30 and 50 is really almost a statistical error at that point. Is that right?
Well, yeah, we think there's some hints there about how they were formed, but we're continuing those studies to try to understand that. But some of our viewers might be confused because I'm saying 30,000 years and 50,000 years. If the flood happened, say, 5,000 years ago, the Genesis flood, how do we get these kind of dates? Well, this comes back to the basic assumption in the carbon-14 technique. You remember at the beginning of the program I said that the basic assumption is that the carbon-14 in the atmosphere has always been the same.
Right.
Well, if the flood really happened, the Genesis flood really happened about 4,000 to 5,000, 6,000 years ago, then there would have been a major change in the ratio of carbon-14 to carbon-12, because the coal and all the material that's buried in the crust of the Earth was organic material that was on the surface of the Earth growing in the atmosphere before the flood.
Okay.
So if you measured the ratio of carbon-14 to carbon-12, it was probably 100 times different. There would probably have been 100 times more carbon-12 in the atmosphere than there is today. So this whole ratio would have been upset by the flood. If you make that adjustment of a factor of something like 10 or so, then you get the 5,000 years instead of the 50,000 years that the conventional estimate comes from. See, the 50,000 years is assuming that the carbon-14-12 ratio is the same now as it was before the flood. But if it wasn't, that can be adjusted dramatically.
Well, where are we going to go with this? What's going to happen in this whole debate about, it seems to me that diamonds are one where, if I were an evolutionist who wanted to prove that diamonds were still billions of years old, I don't know where I'd start.
Well, in fact, that's kind of the response we've gotten from the conventional community. As I've mentioned before, at a conference that we presented these results at, specialists in this area were just astounded by that result, because this is the first time this result had ever been reported in the conventional literature, and it had never been even thought of to do before. In fact, this tells you something about the mindset of a scientist working in the conventional scientific community. They assume everything is old, and they don't even ask the right questions many times.
Right.
So when we got this result, they couldn't explain it, and they were fascinated by it. They encouraged us to continue it, and we understand that there are some people who work in this area that are now doing some of these experiments themselves.
It makes the next few years very exciting for you gentlemen, doesn't it?
Oh, it's wonderful.
There's a whole new debate coming.
Yes.
I do want to share this paragraph. I've read a sentence, but I want to share this paragraph with our folks today. This is the closing paragraph from the introduction to the book that is the conclusion of this 8-year study. And it says this: thus this book opens a new chapter in the origins controversy. As never before, it calls into question the deep time model and places the biblically compatible young Earth model on a level of scholarship never before achieved or archived. Its pages contain many profound thoughts which will shake current scientific orthodoxy to its core. It deserves careful consideration by all of those who value truth. I think you're listening to this show because you value truth. And I think when you hear this kind of evidence, that many of you who perhaps started the show with a closed mind are ending the show with an open mind, where you're saying, here's evidence that we have to look at. Here are some things that simply can't be explained away by billions and billions of years. Perhaps you've been duped. Perhaps you've bought in to the idea that if they say it at school, if it's in the textbook, it has to be true. You know, we put our kids in a real dilemma when we teach them that the Bible says that the earth is just a few thousand years old, and then they go off to school, to high school, and then college, and professors with great authority say the earth is billions and billions of years old. You recognize that if we don't address that issue, we're going to lose our young people, didn't you?
Yes, this is one of the top problems that we have in our educational system today, because science and scientists have such credibility when they say the earth is billions of years old. It really puts us in a dilemma when the Bible says it's only 6,000 years or so old.
Dr. Vardiman and these 8 warriors that have worked with him in the laboratory have opened up a whole new arena of debate in the whole issue of origins. Dr. Vardiman, I want to again share with you my heartfelt appreciation for your dedication and your courageous work. And folks, I want to remind you that this is not just opinion. This isn't just superstition. This is digging into the truth of science because we believe the truth of God's Word. And what we find there is absolutely astounding and exciting. And above all, I want you to remember this: it's God's view that He created you. That should be your worldview too. Hope to see you again next time here on Origins. God bless you till then.
watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 815 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins program number 815, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.